Very good morning, students. Resultant force. First of all, we should know about the concept related with resultant force. Okay. Okay. The first one, the figure shows. One of the figure shows. In here, one of the figure shows a car is pulling by a person in here, but in here the two persons are pushing a car, not pulling, pushing a car. So in both instances, you observe in the first figure only one person applied a force. In the second figure, two people are pushed a car. So in here, if I take, in the first figure, if I take one pupil applied force is considered as F, and in the second figure shows the two pupils are pushing a car. So in here, one consider the both pupils are applied same amount of forces. Here also F, here also F. Or the resultant force is F plus F, both F plus F. The resultant force is 2F. Now we are going to session to clearly know about it. Okay, and then we must know about the concept of resultant force. What is resultant force? What is resultant force? The resultant, in the first figure you observe, the resultant force, the two forces, the resultant force, I call the resultant force is 2F. 2F. The resultant force is F plus F, that is equal to 2F. So I call this is the resultant force. So according to this one, I call resultant force. Now we are going to move the definition of the resultant force. So the single force acting in a place of many forces. The single force acting in a force. This is resultant force. This is a single force. The single force is acting in a places of many forces. The single force that gives the same result as many forces is known as resultant force. Or now we are going to observe when more than one force is applied. Here should be considered, this is not considered, but in here, when more than one force is applied, in the two people, in here two peoples apply the forces. So when more than one force is applied, the single force that gives as the same as the result of the all contributing force is known as resultant force of the individual contributing force. Now we are going to observe the types of the resultant of two collinear forces. Now we are going to observe the resultant forces can be here. We can consider the two main types of the resultant forces. The first one, the result of two collinear forces, the forces having same line of action. The result of two collinear forces having same line of action. And second one, the result of two parallel forces having parallel but different line of action. So you all know about the result of two collinear forces acting same line. Two collinear forces acting same line. Two parallel forces, resultant of two parallel forces, here different line of action. Different line of action. You should know about the main concept difference between the first and second one. Okay? Now, the result of two collinear forces, examples of the two collinear forces, you should know about the examples also. It's also important. The result of two collinear forces when pulling a fishing net Fishing net. This is the one of the example. Sometimes ask for questions, write two examples of result of two collinear forces. This is the one kind of question in your exam papers. I think you are already observed like that questions also. Here, the first one, examples for the two collinear forces. Examples, a group of people pulling a fishing net. Group of people pulling a fishing net. This is an example of the two collinear forces in the same direction and the opposite direction. Example, the two collinear forces can be classified into resultant of two collinear forces can be classified into, first of all observe, result of two collinear forces can be classified into two ways. One is, students, it is also important note it, apply the forces in the same direction, apply forces in same direction. And second one, same direction. And second one, apply the forces in different direction, apply forces in opposite direction, apply force in opposite direction. So in here now we are observe the condition of it. Okay, okay, students, wait. Okay, now we are going to move the activity. Activity 1. In here, you observe one of the figures shows this activity. This is the figure of this activity, right? In this figure, what is the aim of this activity, students? What is the aim of this activity? To find the resultant of collinear forces acting along the same direction. This is the same directions. I already said about the resultant of collinear forces. The first one today we are studying about. First session, resultant force. Then result of two collinear forces. We have observed that two kinds of the main themes related with the resultant force. The first one, two collinear forces, result of two collinear forces in the same line. And second one, result of two parallel forces in the different lines. Result of two collinear forces in the same line, in here same line. Then this is can be classified into two ways. One is same direction, the result of same direction, and this one is opposite direction. This one is opposite direction. And then second we are study about the result of two parallel forces in different line of action. Result of two parallel forces, result of two parallel forces in different direction. So here also we are classified the two parallel forces also can be classified into two ways. The one result of two parallel forces and result of two inclined forces. Result of two parallel forces and result of two inclined forces. Right, now we are going to move the activity result of parallel forces. The aim of the activity to find the result of two collinear forces acting along the same direction. So the first one we observe in here. What are the observations you got? Hello. So the first one we observe the observation method. In here the place the two strings, place the trolley on the table and fix the ring on the one side trolley. I think you already do this practical in your past grade. And now we are going to move the observations. The balance, what is the observation you got in here? The balance B, reading of the balance B 6 Newton and the reading of the balance C 6 Newton. So the Newton balance, reading of the balance A is 12 Newton. And second, here also we take 3 calculations. Here also 3 Newton, 4 Newton, that is equal to 7 Newton. And then 8 plus 6, that is equal to 14 Newton. So through these observations, you take a conclusion, correct? Conclusion, students. So what's the conclusion you can take in here? Here, you can take a conclusion. Balance B plus reading of the balance B and reading in the balance C, that is equal to balance A. Reading of the balance B and balance C, that is equal to balance A. Right. Now we are going to move the conditions of this one. So that is when the 2 collinear forces acting along the, students, you should consider about it. That is when the 2 collinear forces acting along the, acting along the same direction. Resultant force can be classified into, I repeatedly say about, it's very important. The resultant force can be, you all studied about the 2 main forces. One is resultant forces applied on the 2 collinear forces, these 2 collinear forces and parallel forces. Then 2 collinear forces can be classified into 2 ways, the same direction and opposite direction. 2 collinear forces act in the same direction and opposite direction. Now we are going to study about only 2 collinear forces are applied in the same direction. So in this practical too, we take a conclusion. First conclusions, balance B plus balance C, that is equal to balance A. Now we are take a final conclusion of this activity, students. That is when 2 collinear forces acting along the same direction, the result of the 2 forces equal to sum of the 2 individual forces with the direction in the direction of force. So the 2 forces, sum of the 2 forces, balance B and balance C, that is equal to balance A, balance C and the balance C, balance B and balance C, which is equal to balance A. Okay, students, do you have any doubt in this session? I think you have not doubt, or if you have doubt, please chat me. Right, here also one of the question, show it here. Okay, students, that is one of the question. Now you are ready to do it. 2 children are pulling a thread connected. Quickly do it and send your answer through the chat. 2 children are pulling a thread connected to a box placed on a table in the same direction. 2 children are pulling a thread connected to a box placed on a table in the same direction. The force applied by one child is 8 Newton and while that the other child is 6 Newton. So question is, what is the resultant force? First you read the question, then you how to do it. Now we are going to know about how to move this question. Okay, yeah? Okay, the first one. 2 children are pulling a thread. How many children? 2 children. Note it. Then pulling a thread connected to a box. So first you are make a figure. Make a figure. Connected to a figure. Connected to a box placed on the table. Right. How many children? 2 children. Okay. Then same directions. Question. The force applied by one child. 8 Newton. Right. While that the other child is 6 Newton. It's the easy question, I feel. So what is the resultant force is? 8. Here the same direction. So the resultant force, when we apply the force in the same direction, 2 collinear forces acting along the same direction, F1 plus F1 comma F2 here, the resultant force is F1 plus F2. You should mention the directions in which directions force is applied. That directions also the resultant force is acting. So the resultant force is F1 plus F2. So 8 Newton plus 6 Newton, that is equal to the resultant force denoted capital R. So 8 Newton plus 6 Newton, that is equal to 14 Newton. Mostly like that questions posed in the MCQ. Okay, yeah? Right, now we are going to next session. Resultant of two collinear forces. I already say how many times I already said about result of two collinear forces acting along the opposite direction. Now we are going to second type of the resultant force. Okay, yeah? Right, the result of two questions, like that way questions are posed. The first one, they ask the particular, write down the examples of the result of the two collinear forces. Like that questions, you write the answer. The first one, to write two examples, a group of people pulling a fishing net, and second examples, pulling a rope. But particularly mention when particularly mention the question, we must know about how to answer it. The first one, I already many times said, but it is important for your physics session. Okay, resultant force that can be classified into two ways, two collinear forces and two parallel forces. Then two collinear forces can be classified same direction, opposite direction. I think same direction I already explained and finished. In same directions we added, the both forces are added, F1 plus F2. The resultant force is F1 plus F2. And the opposite directions, now we are going to opposite directions. So examples of the two collinear forces in the same direction, pulling a fishing net is an example of the same direction. Opposite direction examples is pulling a rope. That is one of the example of the opposite direction. Pulling a rope. It's also essential. You should know about the verification, students. Right? This is the figure. Now we are going to know about the figure to know about clearly about the two collinear forces are acting along the opposite direction. Now we are take a conclusion. When this tied, you are consider all the people are applied. The force is F3, total force is F1, and in this side F2. Right, now we are going to say about when F1 is equal to F2, what is the conclusion we take? When F1 which is equal to F2, what is the conclusion we take? The pulling a rope does not move any side. Why? You can take an observation when you apply the force in the F1 and F2 in the opposite direction. You observed, what do you observe in here? You observe the rope does not move in this side, east direction or west direction. The rope is moved. What is the reason of it? What is the reason, students? Because in here the resultant force is coming to 0. Which one is 0, students? Resultant force. F1, if take F1 is 5 Newton and F2 is 5 Newton. So resultant force F1 minus F2, that is 5 Newton minus 5 Newton, which is equal to 0. So rope does not move any places, any side. Now, second one we observed. If we apply the force in the F1, if we apply the force in the F1 side, 20 Newton, and the F2 side, 15 Newton. So what is the conclusion, or what is the observation first you got? What's the observation you got, students? I think, what's the observation you got? The object will be moved in the F1 direction. So F1 is west direction. So how do you say about the object will be moved in the F1 direction? How do you say about? You should know about when the forces are applied in the opposite direction should be subtract. When you first to take the conclusion, when you apply the force in the same direction should be added. When you apply the forces in the opposite direction, same direction, it's important, students, same direction, take a small note, and same direction, add the forces. Opposite direction, if the forces is applied in the opposite direction, you should subtract. How to subtract? From the higher value to lower value. From higher value to lower value, you should subtract. Okay, students? Okay, through the way I explain about when F1 is greater than F2, if F1 is greater than F2, the object will move F1 direction, so west direction. So the force is subtract from F1 minus F2. So 20 minus 15, 5, is it correct? No, because should we put the unit also, right? If the object F2 greater than F1, the object move in the F2 direction. The object move F2 direction is direction, right? So this is the one of the concept related with the resultant of two collinear forces acting along the opposite direction. Okay, students, can I move to next session? I think you are clearly know about to. So I move next session. Okay, wait, students. Okay, take your activity. Activity 2. Oh. Okay, activity. Right, first we discuss about the method because it's also important for you. Okay, first of all, here is a one of the trolley, the activity figure. This is the two string, apply the force in here. This is named as B. And then in here also, this another spring balance in here, apply the force. The string name is called as A. We put a name, first name this one. And this is trolley. Okay. The first we should observe the method. The first method, allow the other ends of the pieces and string to passes over the pulling. Right. Now apply the 4 Newton forces on each balance. First condition, apply the Newton forces in the each balance. Balance A, apply 4 Newton. And balance B also apply 4 Newton. Okay, so what is the observation you got, students? I already explained. In the two collinear forces acting along the opposite direction, we use the condition. The first one, when the F1 which is equal to opposite direction, apply the forces F1 which is equal to F2, the object comes to rest because resultant force 0. Okay, resultant force 0. Okay, and second condition, when F1 greater than F2, the object move F1 side, which is the side because the resultant force F1 minus F2, the value, which one is have the value greater value? F1 force. So subtract from the F1 to F1 minus F2. So the object move in the F1 direction. And third condition, F1 lesser than F2. So the object move F2 direction. Okay, students? The three conditions you should apply in here. The situation A, in the situation, we use the three situation in here, such as the first situations, applying a 4 Newton force in each balance. The balance A, balance B. So, applying 4 Newton, in the balance A, 4 Newton, and balance B also, 4 Newton. So, the result, the trolley in here, what is the observation you got? Trolley does not move. Trolley does not move. So, this is the observation you got this activity. Okay, and the reason for is, it's also important. The reason for is because the trolley remains its equilibrium under the actions of two equal forces acting on an opposite direction. And second one, applying 4 Newton on the balance A. So in the balance A, applying 4 Newton, and balance B, applying 6 Newton. So which is the balance has higher Newton. So balance B, so the resultant force is 6 Newton minus 4 Newton. That is equal to 2 Newton. So the trolley moves towards the B balance. The trolley moves in the direction of the Newton balance B. So the reason is there are two unequal forces acting on the trolley in the opposite directions. And the trolley moves in the direction of the larger forces. And the third instance, applying of 6 Newton forces on the balance B and the balance A. So the object trolley does not move. So the result, because the resultant force is 0. So the two forces acting in the opposite directions become equal. Through the way the trolley does not move. Okay, yeah? So this is the activity 2 students. Right, then now we are going to do here also one of the examples show here. What is the magnitude and the direction of the result of forces? Force of 6 Newton pulling an object placed on a table in a certain direction, and another force of 4 Newton pulling it in the opposite direction. So the resultant force is, now we are going to observe the question. What is the magnitude and the direction of the resultant force? This is the question for you. 6 Newton pulling an object placed on the table in a certain direction, and another force 4 Newton pulling it in the opposite direction. So first show the figure. First in here 6 Newton force applied in the one direction and another force applied in 4 Newton applied in opposite direction. So the resultant force is F1, this is F1 consider, this is F2, so F1 greater than F2. So 6 Newton minus, in here we can apply a condition F1 minus F2. So 6 Newton minus is equal to 4 Newton, that is equal to 2 Newton. Now, can we move the next session, students? Result of two parallel forces. Result of two parallel forces. So, when in here we can apply when two forces acting along the same direction, the result force is the sum of the two forces. When it is acting in when two forces are acting along the same direction, the result force is the sum of the two forces. So resultant force, that is equal to A plus B. A plus B. Now we are going to observe the figure to know about it. So in order to find out the result of two parallel forces acting along the same direction, the two forces must be added. Right? This is the condition, students. This should be know about. Right. Now we are going to do one of the question. Two strong strings attached to a trolley. Two strong strings attached to a trolley. First draw a trolley. First draw a trolley, students. Okay. Read the question. Two strong strings attached to a trolley is pulled by force 20 Newton on one string and a force of 50 Newton on the other string. Right. 20 Newton on one string and another string applied 15 Newton. Keeping the two strings parallel. Keeping the two strings parallel, you should know about the parallel lines does not meet any point. So questions is find the resultant force. So both forces are applied in the same direction. Both forces are applied in same direction. So 20 Newton plus 15 Newton, which are applied in the same direction. So the resultant force, what is the condition? When the forces are acting in the same direction, should be added. So 20 Newton plus 15 Newton, which is equal to 35 Newton. This is the sum. Okay. Now we are going to next one. In here, another practicals also in your book. Observe, students, in your books. One of the practical that is does not show here. Activity 3, students. Observe. It's important for you. This is the strip. This is the practical important because I do some of the question too. You know about why it is important for you. This is set, name as set, and this is name as in here a balance, Newton balance is applied. That is named as A, and in here Y. This is X, this is Y. The Newton balance B, and then another Newton balance attached in the point Z, C. So first upon, what is the aim of this activity, students? What is the aim of this activity, right? So aim is to find or to calculate the resultant of two parallel forces to calculate. So aim is to identify or calculate, to identify the resultant two parallel forces, to identify the resultant force of two parallel forces. Right. Okay. Now observe. In this practical, we applied both equal amount of forces in A and B. What is the reason why we apply the both amount of forces in the balance A and the balance B? Why? What is the reason? Because the balance should be perpendicular to strings, or balance should be perpendicular to strip. Why we apply the same amount of equal amount of forces in A and B? Because the Newton balance should be perpendicular to strip. Newton balance should be perpendicular to strip. And another question for you. Now, then we observe the observation when we apply 4 Newton in the A and the B also 4 Newton. So reading of the C, which is equal to 4 Newton plus 4 Newton, 8 Newton. That's the reading of the balance C. And second one, you should consider when you arrange this practical, you should consider the distance between the set X, which is equal to distance between the Z, Y. This is also one of the factor also. Then resultant, so what is the beneficial of the resultant force? It is also essential for you. What is the beneficial of the resultant force? You know about the beneficial of the resultant force, students, to make use of large number of small forces in the place of single large force effectively. A large force, when we apply the large force in a place, we applied many small forces to move the large amount of force. That is the one of the beneficial of the resultant force, students. And then result of the two inclined force, in here you observe right. In here you can, this is the irregular shape of the object. Students, time continue pannavanam. Questions konjam irukkudu. So result of the two collinear forces, two inclined forces, when apply the force in the P and apply the force in the Q. Right. Now investigates how to, what is the resultant force of like this setup. So the resultant force is passes through between the, in which side the more amount of force is applied, that side the resultant force is mostly so. If the force P is greater than Q, the resultant force is moved towards the P. So PQ, resultant force is moved towards the Q, sorry, towards the P. And if the force is greater than Q is greater than P, the resultant force is moved towards the Q. So I think this is the theory section. Now after the stop, we are continue to question bank. This is the questions which are related with, now we are studied about session. So first you do and send your answer through this chatting way to send your answer. Then I explain, students. This is the time for your time. Now you are start to do these questions.